It is late and I am sleepy, but I feel strangely motivated to do SAT problems, so I will do SAT problems. So we'll start a new test. This is going to be test 2, and we're going to start on section 3, and that's on page 459 of the, what's that book called? The Official SAT Study Guide by the College Board. So let's get started. So the first problem, problem number 1. It said if 3b plus 1 is less than 10, which of the following cannot be the value of b? So which of the following cannot be the value of b? And they gave a couple of choices. A minus 1, B 0, C 1, D 2, E 3. And you could, really you could start with choice A and just keep going through all of them and inspect it really fast. The way I would do is I would automatically convert this equation, subtract 1 from both sides, and you say, well, this is the same thing as 3 times b has to be less than 9. I just subtracted 1 from both sides of this, right? And if you look at these, well, 3 times negative 1, that's negative 3, that's less than 9. 3 times 0, that's 0, that's less than 9. Let me write that. 3 times negative 1 is negative 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. These are all less than 9, right? I just substituted each of these for b. But 3 times 3, that is actually equal to 9, right? 3 times 3 is equal to 9, which is not less than 9. So our choice is E. Number 2, I think I have space to do it on this without having to clear the chalkboard. It says 2 to the 4x is equal to 16. Whenever you see one of these problems where the variable is in the exponent and you have different bases here, the trick is really just to convert them to the same base. So can I write 16 as a power of 2? Well, sure. What's 2 to the what power is 16? Well, 2 to the squared is 4, to the third power is 8, to the fourth power is 16, right? So we could write this same equation as 2 to the 4x is equal to, another way of writing 16 is 2 to the fourth power, right? And now this should seem a little bit more straightforward. 2 to the 4x is the same thing as 2 to the fourth, so 4x must equal 4, right? 4x must equal 4, and so x is equal to 1. And that choice exists, so I feel confident in my answer. Let's move on. I think I might be coming down with the flu. Let's hope not, because that would limit my ability to churn out SAT problems on YouTube. Number 3. How much greater is r minus 2 than r plus 5? R minus 2 than r plus 5. Well, if I wanted to know how much one number is greater than another, if I asked you how much greater is, 10 than 5, what do? Well, I take 10 minus 5, and that's my answer. So example, 10 minus 5 is 5. So 10 is 5 greater than 5, right? So if I want to know how much greater than r minus 2 is r plus 5, right? And r plus 5 is going to be the greater one. You just subtract them. So we say r plus 5 minus r minus 2. So r plus 5 minus r, I'm just distributing the negative number, plus 2. The r's cancel out, and you get the answer is 7. And you really didn't even have to do it this way, because this r could be any number, and the answer should be the same no matter what r is. And obviously it worked out because the r's canceled out. But the easiest thing would be, let me just assume that r is 0, because we can, because it shouldn't matter what r is. So if r was 0, then the question is how much greater, how much greater than negative 2 is plus 5, right? I just assumed that r is 0. And then you would do the same thing. You do 5 minus negative 2, which is equal to 7. And you could draw them on the number line if you wanted to visually approach this problem. All right, this next problem. This one looks visual. Problem number 4. Okay, so it has a square. It looks, actually I don't need to draw it fancy. Let me just draw it freehand, because so it's a box. It looks like this. It looks something like this. Dum da dum da dum 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 dum. And they say that the box is open at the top. The box is open at the top, so that's the bottom right there. Okay, and they give measurements. This end is 4, this end is 3, and then the height is 2. And then they were to say, if we were to essentially, cut the sides of this box and then flatten it all out, which of these choices are this box? And this is a pure visualization problem. But to flatten it out, as I said, you would cut this line. You'd cut this line. Like, I'm just imagining what I would do if I had some scissors, and there's no top to the box, right? And then I would take this side and I would flatten it out that way. This side I would flatten it out that way. That back side I would flatten it out there, and that side I would flatten it out there. And so what would be I left? So you'd have the base. So the base would look like this, where you have 3 would be this kind of the width, right? This side corresponds to this side, right? This side would correspond to this side, and that would be of length 4. And then this height 2, let me draw that. So this flap, which I draw in brown, that flap would come out like this, would come out flat like that, and this distance right here would be 2. And then you would have another, let's say this flap in the back, let me draw it in another color, draw it in a dark purple. This flap in the back would come out like this, flat. It would also have 2 length. And then the other 2 flaps, like this one, this flap would come out like this. And of course this has 2 here. And then finally I have that flap in the back. Let me pick a color. It says, this flap in the back would come out like that. Right? And I'll shade it in like I shaded it in the original picture. And that would also have 2. So this is a pure visualization problem. Hopefully there's not a lot more that I can do to explain this. And there was no top to this box. And then we had a bottom. And this would look like. So this is the choice. Let's see, if we rotated it around a little bit, it's choice E. They actually rotate it around because choice E looks like this. Choice E looks like this. I'm not drawing it that well, but it looks something like this, where they say that this length is 4, this length is 2, and this length is 3. So they took this and they essentially rotated it so that this side becomes this side, and then this side becomes that side. So they just rotated it clockwise, about, what is that, a little over 90 degrees. And that's how they got that answer. So this is a pure visualization problem. With that, I have about 90 seconds left in this video. So I'll wait to do it in the next video. I'll see you soon.